Hey, Kaden, I'm going to try and walk you through that homework problem. Let's keep in mind that this function is measuring the distance, so how far away a weight is from the ceiling. So this weight is being suspended from the ceiling and it's bouncing, right? Once we pull on the weight, it's going to bounce. So its distance from the ceiling is going to change. So you can see here that your graph shows at time t equals 0. I labeled it at point A. That weight is at its furthest distance from the ceiling. It's 16 centimeters away from the ceiling. So if you take a look at the picture that I drew on the right here, it kind of showed you, okay, let's imagine that this is the ceiling. And then we can see that if that weight is 16 centimeters away from the ceiling, you can see it's been stretched down, right? And then it starts to, the weight is going to bounce back up. So as it's bouncing back up, we can track that at point B. You can see it's halfway up, it's coming back up. So it shows that it's only 11 centimeters away from the ceiling. And then at point C, we can see that it has gone to it's 6 centimeters away from the ceiling. So it's closest to the ceiling at point C because it's only 6 centimeters away, whereas it's the furthest from the ceiling at point A and point E because we can see that at 16 centimeters, that's the furthest distance away from the ceiling it is. And so I also made a table on the left here so you kind of see over time, right, how far away that weight is from the ceiling. So I hope this kind of helps you visualize like that weight bouncing from its lowest point where it's furthest away from the ceiling at 16 centimeters, and then it bounces back up to where it's the closest to the ceiling because it's only 6 centimeters away from the ceiling. So I hope that this information will help you answer those questions. So, like in question D, where it says, what is the furthest the weight gets from the ceiling from your problem? You can see here that it's 16 centimeters. Okay, I hope that helps.